work power energy. Okay.
Sir, 5 minutes, sir. 5 minutes. 1 minute, 1 minute.
Yes, good afternoon, everyone. Today, let us discuss about work, energy, and power. Work, energy, and power.
Sir, hello,
Okay.
Sir. 1 minute, sir.
So, first of all, discuss about work
Sir.
done by constant force. Work done by constant force. Work done by constant force. Okay. So work done is equal to work done is defined as a product of component of force and displacement is called a work done. Component of force W is equal to F cos theta. F cos theta into S. W is equal to F cos theta into S. W is equal to Fs cos theta. W is equal to Fs cos theta. So W is equal to dot product F bar W is equal to F bar dot S bar. Dot product of force and displacement is called work done. Force and displacement is called work done. We know that work done units of work done is joules. 1 joule is equal to 10 to the power of 7 erg. 1 joule is equal to 10 to the power of 7 erg. So work done 1 electron volt, 1 EV is equal to 1.6 into 10 to the power of minus 19 joules. 1 EV, 1 electron volt is equal to 10 to the power of minus 19 joules. Next, so 1 kilowatt hour is equal to 1 kilowatt hour. 1 kilowatt hour is equal to 3.6 into 10 to the power of 6 joules. 3.6 into 10 to the power of 6 joules. Okay. Next, work done by multiple forces. Work done, nature of work done. Nature of work done. Nature of work. Nature of work. So work done by force may be either positive or negative or zero work done. Work done may be positive work or negative work or zero work. Positive work. Second one, negative work. Negative work and zero work. Third one is zero work. Zero work. Okay. So positive work, force and displacement both are same direction. Work is positive. Work, force and displacement both are in same direction. Force F and displacement S. Both are same direction. Theta is equal to 0. W is equal to Fs cos theta formula. Fs cos theta. Theta 0. Cos 0 value 1. W is equal to Fs. So then work is positive. Then work is positive. Okay. Next, second one, work is negative. Work is negative. Force and displacement opposite direction. Theta is equal to 180. Theta is equal to 180. W is equal to Fs cos theta. We know that formula. W is equal to Fs cos theta. Theta 180 cos 180 value minus 1. Cos 180 value minus 1. Cos 180 minus 1. So W is equal to minus Fs. Then work is negative. Then work is negative. Next, zero work. Zero work or null work. Zero work or null work. In this three conditions is there. First condition, if force is zero, then work is zero. Force is zero, work is zero. Second condition, if displacement is zero, then work is zero. Third condition, three conditions, if force and displacement are mutually perpendicular, F and force is perpendicular to S, then theta is equal to 90. Theta is equal to 90, cos 90 value 0. Cos 90 value 0. Then W is equal to Fs cos 90. Work is 0. Work is 0. These are nature of work. First, positive work, negative work, and zero work. Positive work, negative work, and zero work. Next, work done by variable forces. Next concept, work done by variable forces. Work done by variable forces. Variable force. Work done by variable forces. Okay. So this is from A to B. This is A point. This is B point. Okay. Force direction. Force F. Small displacement is ds. Small displacement is ds. This angle is displacement and angle is theta. Angle is theta. So work done W is equal to, we know that force dot product of force and displacement. dW is equal to F bar dot ds. F bar dot ds. So work done of AB is equal to dW is equal to integral F into ds with the limit A to B. That is equal to integral F cos theta F bar dot S bar. Integral F bar dot S bar. That is equal to integral F cos theta into ds with the limit A to B. So in terms of rectangular components, in terms of rectangular components, suppose F in vector form, F is equal to Fxi plus Fyj plus Fzk. This is vector form. So ds is equal to dxi plus dyj plus dzk. ds is equal to dxi plus dyj plus dzk. So now find out work done. W is equal to integration of fx into dx with the limit A to B. Plus integration of fy into dy with the limit A to B. So integration of fz into dz with the limit A to B. This is work done by variable forces. So you work done applications, small applications of work done. Application of work. So suppose if a force is changing linear from F1 to F2, force is changes from F1 to F2 over a displacement of S, then work done is equal to force is changes F1 to F2 over a displacement S, then work done is equal to average force F1 plus F2 average force into displacement. This is one formula. W is equal to F1 plus F2 by 2 into S. F1 plus F2 into by 2 into S. So another formula. Suppose in vector form S is equal to final position and initial position. Displacement is equal to changes of two positions is called displacement. So work done W is equal to F bar dot S bar, that is equal to F bar into S bar RF minus RA. RF minus RI. This is another formula. Okay. Next, third application. Suppose this is a simple pendulum. Mean position of the simple pendulum. This is the extreme position of the simple pendulum. Extreme position. So total length is L. Total length is L. Total length is L. Okay. So remain this length is H height. Remaining height L minus H height. Total length L from A position to B position, height is H. This is C position. This is O. Angle is theta. Angle is theta. So weight of the body downward direction, we know that mg. Weight of the body is downward direction. This is pulling force F. Tensional force is T. Tensional force is T. So ikkada theta angle chestundi kabatti this is opposite. This is opposite. So okay, adjacent. This is hypotenuse. Okay, from figure cos theta is equal to adjacent by adjacent and the L minus H adjacent L minus H by L by L. Cos theta is equal to L minus H by L. So cos theta is equal to L by L 1 by H by L. So 1 you will say H by L is equal to 1 minus cos theta. H is equal to, so L into 1 minus cos theta. L into 1 minus cos theta. So work done by gravitational force. work done by gravitational force. Work done by gravitational force. W is equal to minus mgh. W is equal to minus mg into h. This one represents L into 1 minus cos theta. L into 1 minus cos theta. This is another formula. W is equal to minus mgl into 1 minus cos theta. W is equal to mgl into 1 minus cos theta. Okay. Next, another formula. So a body of mass m is a slide down on smooth inclined plane. This is inclined plane. This kunte smooth inclined plane. M mass of the body is placed on inclined plane. So weight of the body is a downward direction mg. We know that weight of the body is downward direction. Normal reaction is upward direction n. So this weight is divided into two components. One is mg cos theta. Another one is mg sin theta. Okay. So we know that n normal reaction is balanced with mg cos theta. Yesterday class lo already cheppunnam. So this is mg sin theta is a downward direction. So body is moved from height from this is ABC. down from C to A. C to A. Displacement S is equal to mg sin theta. Force L. Displacement is L. Total length. Displacement S is equal to L. S is equal to L. Force is equal to mg into sin theta. Mg into sin theta. So work done is equal to, what is formula? W is equal to Fs. So W is equal to mgl, mg sin theta into L. Mg sin theta into L. This is work done. This is work done. Okay. Work done. Suppose a rough inclined plane. This is a smooth inclined plane. Smooth inclined plane. Smooth inclined plane. Suppose a rough inclined plane. Rough plane. Rough plane W is equal to formula. Rough plane W is equal to mgl into sin theta minus mu k cos theta. Sin theta W is equal to mgl into sin theta minus mu k cos theta. Rough inclined plane. Malli diagram ele ikkada ano. Sin theta into mgl cos theta. Okay. Now discuss about potential energy. Potential energy. Potential energy. What is formula potential energy? Potential energy. Capacity to do. Potential energy. The energy possessed by the body by virtue of its position is called a potential energy. Potential energy, we know that formula P is equal to mgh. Potential energy P is equal to mgh. Potential energy P is equal to mgh. So F is equal to changes of potential energy. Force is equal to changes of potential energy. F is equal to minus du by dr. So du is equal to F into dr. Du is equal to F into dr. So integral du is equal to with the limit u1 to u2 minus integration of F into dr with the limit r1 to r2. With the limit r1 to r2. This is a delta integration of delta u. So applied the limit u2 final limit minus upper limit. So u2 minus u1 is equal to minus integration of F into dr with the limit r1 to r2. This is reference work done. This is reference work done. Minus work. So therefore formula in this u1 is equal to 0. Epudu r1 is equal to infinity. R1 is equal to infinity. U1 is equal to 0. U1 is equal to 0. Potential energy U is equal to integration of F into dr with the limit infinity to r, that is equal to minus work done. This is formula potential energy. Next, we know that kinetic energy. What is for definition of kinetic energy? The energy possessed by the body by virtue of its motion is called a kinetic energy. K is equal to half mv square. We know that. So we know that the relation between kinetic energy and Ke and momentum. Kinetic energy and momentum. So kinetic energy formula K is equal to half mv square. K is equal to half mv square. K is equal to half mv square. So what is momentum formula? P is equal to mv. So K is equal to half mv square multiplied and divided by m. M to multiply is m to divide చేస్తున్నాం. దీని ఏం రాయొచ్చు? m square v square by 2m. m square v square by 2m. Ke is equal to, so mv is equal to p. This is p square by 2m. This equation represents relation between kinetic energy and momentum. Kinetic energy and momentum. Okay. Next. Conservative and non-conservative potential energy of the spring. Potential energy of the spring. Next, discuss about potential energy. Potential energy stored in a spring. Potential energy stored in a spring. So we know that du is equal to u is equal to integration of f into dx with the limit 0 to x. 0 to x. F is equal to kx. F is equal to kx. Spring constant. K represents spring constant. K represents spring constant. dw is equal to minus. So integration of this is kx into dx. F place lo substitute చేసిన అక్కడ. F place లో substitute చేస్తే f is equal to kx. F is equal to kx. So integral with limit. So du is equal to minus k into integration of x square into integration of x into dx. This x square by 2. X square by 2. So du is equal to minus x square by 2. Minus of minus plus. Minus of minus plus. That is equal to 1 by 2 kx square. 1 by 2 kx square. దీనికి ఇంటిగ్రేషన్ చేస్తే u2 minus uf minus ui వస్తుంది. uf minus ui is equal to changes of potential energy. Changes of potential energy. This equation represents potential energy stored in the spring. This equation represents potential energy stored in the spring. So we know that work energy theorem. Already మీకు తెలుసు ఇది. Work energy theorem. Work energy theorem. Work energy theorem. So work energy theorem ఏం చెప్తుందంటే total work done is equal to changes of kinetic energy. Total work done W is equal to changes of kinetic energy. Kf minus Ki. Changes of kinetic energy. W is equal to Kf of mv square minus of mu square. Changes of kinetic energy. Changes of kinetic energy is represents work energy theorem. Kf minus Ki. Okay. Next. ఇక్కడ దాకా వర్క్ ఎనర్జీ గురించి డిస్కస్ చేసినాం. పవర్ నెక్స్ట్ క్లాస్ లో డిస్కస్ చేద్దాం. ఓకే, ఇప్పుడు వరకు మనం డిస్కస్ చేసినటువంటి ఫార్ములాస్ పైన ప్రాబ్లమ్స్ చేద్దాం. ఓకే, ఎస్ ప్రాబ్లమ్స్ చూద్దాం. మళ్ళీ ప్రాబ్లమ్స్ problem. Yes, observe that first problem. Yes, first problem. Work done by constant force concept. So what is given first problem? If F is equal to 2i plus 3j plus 4k act on the body and displacement it by S is equal to 3i plus 2j plus 5k, then work done by the force is. So what is given? Force is given in vector form. Displacement is given. F is equal to S is equal to. So now find out work done. So options, first option 12 joules, 20 joules, 32 joules and 64 joules. 64 joules. Okay, write down first problem first. Yes, solution. So what is formula work done? W is equal to dot product of force and displacement is called work done. Dot product of force and displacement is called work done. So first of all, write given values. Force is given, F is equal to 2I plus 3J plus 4K, vector form. Next, displacement is also given. Force displacement 3I plus 2J plus 5K. Now find out work done. What is formula? W is equal to dot product of force and displacement is called work done. So substitute the value. So W is equal to force 2I plus 3J plus 4K dot S, the displacement 3I plus 2J plus 5K. So W is equal to, so we know that I dot I is equal to 1. 2 into 3, 6. I dot I is equal to 1. 1 into 6, 6. Next, 3 into 2, 6. J dot J 1 plus 4 into 5, 20. K dot K is equal to 1. So W is equal to, so 12, 20, 32. What is units of work? Joules. W is equal to 32 joules. Yes, option is there. Third option. Next problem. Second one. Second problem. A force of 1200 Newton. A force of 1200 Newton acting on stone by means of rope slides the stone through a distance of 10 meter in direction inclined at 60 degree to the force. The work done by the force is, what is given? Force is given and distance of 10 meter, direction inclined at an angle 60 degrees. Theta is given, force and displacement. Now find out work done. Okay. So force F is 1200 Newton and displacement S is equal to 1200 Newton means of force. S is equal to 10 meter. Theta is equal to 60 degree. W is equal to, what is formula? W is equal to Fs cos theta. Substitute the values. W is equal to 1200 into 10 into cos 60 into cos 60. Okay. W is equal to 1200 into 10, 12,000. So cos 60 value, cos 60 1 by 2. These two get cancelled. So W is equal to 6,000. Joules. Yes, option is there. 6,000 joules. Second option. Next, third one. Fourth one chedama. Yes, fourth one. The work done by force. Fourth one. The work done by a force. F is equal to 3I minus 4J plus 5K. Displace the body from point 3, 4, 6 to point 7, 2, 5 is. So in this 2 points is given. 2 points 3, 4, 6 and another point 7, 2, 5. So assume that this is R1 point. This is R2 point. Find out the displacement. S is equal to R2 minus R1. R2 minus R1. Force is given. Find out work done. Find out work done. Okay. So F is equal to 3I minus 4J plus 5K. So 2 points is 2 points. First point 3, 4, 6. Another point 7, 2, 5. 7, 2, 5. You know that displacement S is equal to R2 minus R1. So subtract these two. That is equal to, this is X1, Y1, Z1, X2, Y2, Z2. 7 minus 3. 7 minus 3. 4. 2 minus 4 minus 2. 5 minus 6 minus 1. So write in vector form. That is equal to 4I minus 2J minus K. So you know that W is equal to W bar is equal to F bar dot S bar. W is equal to F bar dot S bar. Substitute the values 3I minus 4J plus 5K dot 4I minus 2J minus K. So W is equal to 4I. So 4 into 3, 12. I dot I, 1. This is minus 4 into minus 2. 8. 8 plus 8 plus 8. Next, minus 5 into 1, 5. So that is equal to 8 plus 12, 20. 20 minus 5, 15. What is units of work? Joules. W is equal to 15 joules. W is equal to 15 joules. Okay. Next. First option is correct. First option. First option is correct. Next problem. Next problem. Yes. Sixth one. A lawn roller is pulled along a horizontal surface through a distance of 20 meters by rope with the force of 200 Newton. If the rope makes an angle 60 degrees with vertical though 60 degrees undi, while pulling the amount of work done, the pulling force is. Now find out work done. What is given? Lawn roller along horizontal surface, distance is 20 meter. Force is 200 Newton. If the make an angle vertical to 60 degrees undi. Okay. So write down problem options. First option 4000 joules. Second option 1000 joules. Third option 2000 root 3. And fourth option 2000 joules. 2000 joules. Okay. So sixth one. This is horizontal surface. Roller. Okay. Roller, this horizontal surface distance is 20 meter. S is given. S is equal to 20 meter. And force 200. Pulling force or pushing force? If the make an angle 60 degrees vertical with pulling force. This is pulling force. Pulling force is given. Pulling force is equal to F. F is equal to 200 Newton. So this pulling force pulling force resolved into two components. Divide into two components. One is horizontal component, another one is vertical component. Okay, F cos theta and F sin theta. So horizontal component F cos theta, vertical component F sin theta. F sin theta. So angle is given. If rope an angle 60 degree with vertical to 60 degrees. Vertical angle 60 degrees. మళ్ళీ హారిజంటల్ యాంగిల్ ఎంత ఉంటుంది 30 degrees. ఎందుకంటే వర్టికల్ కి హారిజంటల్ కి ఎంత యాంగిల్ టోటల్ 90 degrees. కానీ వాడు ఏమి ఇష్టం అంటే ఫోర్స్ బిట్వీన్ వర్టికల్ యాంగిల్ 60 degrees. సో హారిజంటల్ యాంగిల్ ఫోర్స్ విత్ హారిజంటల్ యాంగిల్ force with horizontal angle is 30 degrees. Theta is equal to 30 degrees. మనకి ఏం ఇచ్చినారంటే యాంగిల్ ఇచ్చినారు కదా theta అని 60 అని అప్లై చేసేస్తాం. ఆన్సర్ రాంగ్ వస్తుంది. సో వాట్ ఈస్ ఫార్ములా? W is equal to Fs cos theta. Fs cos theta. W is equal to F 200 into S 20 into cos 30 into cos 30. W is equal to 200 into 20 into cos 30 value. Cos 30 value root 3 by 2. Root 3 by 2. These two get cancelled. So W is equal to 200 is 10. So 10 into 200, 2000. 2000 into root 2. 2000 root 2. Yes, option is third option. Third option. Third option. Next. Seventh one. Seventh problem. Observe that seventh problem. Seventh one. Work done by a variable force concept. Work done by a variable force and concept paina oka problem. An object has displacement from position vector r1 is equal to 2i plus 3j, r2 is equal to 4i plus 6j meter under force F is equal to 3x square I plus 2yj. Then work done by the force is okay. Once again, an object has a displacement from position vectors r1 is equal to 2i plus 3j, r2 is equal to 4i plus 6j meter under the force F is equal to 3x square I plus 2yj. Then work done by the force. సో ఇక్కడ ఇంటిగ్రేషన్స్ బాగా వస్తే మనకి మ్యాథ్స్ లో ఇంటిగ్రేషన్స్ తెలిసింటే ఈ ప్రాబ్లమ్ ఈజీగా సాల్వ్ చేయొచ్చు. సో ఆప్షన్ ఫస్ట్ ఆప్షన్ 24 జౌల్స్, సెకండ్ ఆప్షన్ 33 జౌల్స్, థర్డ్ ఆప్షన్ 83 జౌల్స్ అండ్ ఫోర్త్ ఆప్షన్ 45 జౌల్స్. ఓకే, సాల్వ్ చేద్దాం. మళ్ళీ ఇది లెంత్ అవుతుంది ప్రాబ్లమ్, దీన్ని డ్రాప్ చేస్తా ఇక్కడ. Next, problem number 7. First of all, write given values. Force F is given. F is equal to 3x square I plus 2yj. 2yj. So this is force. And two position vectors R1 is equal to 2i and 3j. R2 is equal to 4i plus 6j. R2 is equal to 4i plus 6j. So ikkada R1 is equal to x1 comma y1. ఇదేం రాయొచ్చు xi plus yj కదా. R1 is equal to, this is x1, this is y1, this is x2, y2. So x1 comma x2 is equal to x1 y1 x2 y2, x1 y1 x2 y2. Now find out work done. What is formula work done? W is equal to force into integration of, direct formula rasa, integration of fx into dx plus integration of fy into dy with limit, this is y1 to y2 with limit x1 to x2. So once again formula, W is equal to integration of fx into okay, once again problem number 7. Problem number 7, R1 is equal to 2i plus 3j, 2i plus 3j, and R2 is equal to 4i plus 6j. So this is x1, this is x2 y2, this is x1 y1. So x1 comma y1 is equal to 2 comma 3, x2 comma y2 is equal to 4 comma 6. So force is given, F is equal to 3x square I plus 2yj. So now find out work done. What is formula? W is equal to integration of fx into dx with the limit x1 to x2 plus integration of fy into dy with the limit y1 to y2. So W is equal to integration of fx. Fx means 3x square into dx with limit x1 to x2 2 to 4 plus integration of fy is 2y 2y into dy with the limit y1 to y2 through 3 to 6. 3 to 6. W is equal to, we know that integrations. So 3 into integration of x square. Integration of x square into dx with the limit 2 to 4 plus 2 into integration of dy into dy with the limit 3 to 6. So we know that formula, integration of x power of n into dx is equal to x power of n plus 1 by n plus 1. Integration of x power of n into dx is equal to x power of n plus 1 by x power of n plus 1 by n plus 1. Similarly, in this integration of x square, integration of x square into dx, so x power of 2 plus 1 by 2 plus 1, x cubed by 3. Okay, so w is equal to 3 into the integration ento vastundi x cubed by 3 with the limit 2 to 4 plus 2 into integration of y into dy, this is y square by 2 with the limit 3 to 6, with the limit 3 to 6. So w is equal to, in this 3 get cancel, upper limit minus lower limit. X place lo 4 ఒకసారి substitute చేయాలి, x place lo 2 ఒకసారి substitute చేయాలి. Upper limit minus lower limit. So 4 cubed minus 2 cubed. 4 cubed minus 2 cubed plus, in this 2 get cancel. So upper limit minus lower limit, 6 square minus 3 square. 6 square minus 3 square, that is equal to 4 cubed, 4 into 4 into 4, 4 4 ja 16, 16 4 ja 64 minus 2 cubed 8, 2 into 2 into 2 plus 6 square 36 minus 3 square 9 minus 9. W is equal to, so 64 minus 8, 56. Yes, 56. This one 36 minus 9, 27. So add these two plus 56, yes, 83. So what is units? Work done is equal to 83 joules. 83 joules. సో మీకు ఇంటిగ్రేషన్స్ కొంత ఐడియా ఉండదని నేను కొంత లెంతీ చేశాను, లేకపోతే డైరెక్ట్ స్టెప్స్ చేసుకుంటూ రావచ్చు, ప్రాబ్లమ్ షార్ట్ కట్ అయిపోతుంది. సో ఇంటిగ్రేషన్స్ ఉందో మీకు తెలుసో లేదో అన్నట్టుగా కొంత లెంతీ చేశాను. ఓకే, డీటెయిల్ గా చెప్పాను. రైట్, నోట్ చేసుకున్నారా? రైట్ డౌన్ ప్రాబ్లం నెంబర్ 7, 7th one. Yes, next one. Yes, ఇది ప్రాబ్లం. ఎంత వచ్చింది ఆన్సర్? థర్డ్ ఆప్షన్ 83 joules. 83 joules. 83 joules. Okay. Next problem. 10th problem. The mass of a simple pendulum bob is 100 grams. The length of the pendulum is 1 meter. The bob is drawn aside from equilibrium position so that the string makes an angle of 60 degrees with vertical and let go. The kinetic energy of the bob while crossing its equilibrium positions will be. So what options? First option 0.49 joules, second option 0.94 joules, third option 1 joules, fourth option 1.2 joules. సో సింపుల్ పెండులం అంటాడు. నేను అప్లికేషన్ చెప్పేటప్పుడు ఫార్ములా చెప్పాను, W ఈజ్ ఈక్వల్ టు, సో మనం ఏం ఫైండ్ అవుట్ చేయాలా? కైనెటిక్ ఎనర్జీ. కెపాసిటీ టు వర్క్ ఈజ్ కాల్డ్ ఎనర్జీ. సో నౌ ఫైండ్ అవుట్ వర్క్ డన్. ఫైండ్ అవుట్ వర్క్ డన్. ఓకే, ఎస్. 10th problem. 10th one. Tenth problem. What is given? A mass of simple pendulum bob is 100 grams. M is given. M is equal to 100 grams. 100 grams. The length of the pendulum. Length of the pendulum is 1 meter. The bob is drawn aside the equilibrium position and the string makes an angle. Angle is given. Angle is equal to 60 degree. Angle is equal to 60 degree. Now find out kinetic energy. What is find? Kinetic energy. So we know that this figure. So this is mean position. This is extreme positions. Okay. This is H side. Angle is theta. So in the more applications lo apply cheskunnam. So direct rasam formula. W is equal to, what is formula? W is equal to mgl into 1 minus cos theta. mgl into 1 minus cos theta. So now find out kinetic energy, work a kinetic energy, Ke. Okay, W is equal to m value 100 grams. This grams is converted into kg. Grams is converted into kg. So 100 into 100 grams is converted into kg. 100 into 1 gram is equal to 10 power of minus 3 kg. So 100 into 10 power of minus 3. 100 into 10 power of minus 3. 100 into 10 power of minus 3 ante this is 100 into 10 square. So 10 power of minus 1 direct rachu. 10 power of minus 1. 10 power of minus 1. M value 10 power of minus 1. ఇక్కడ రాసిన detail into G. G is 10. L length is 1 into 1 minus cos 60. 1 minus cos 60. So W is equal to this one 10 power of minus 1 into 10. ఏమవుతుంది 1. These two cancel. 10 power of minus 1 10 cancel. 1 into ఇది 1 అవసరం లేదు. 1 minus cos 60. 1 minus cos 60 value 1/2. Cos 60 value 1/2. 1/2 లేదు కూడా G వాల్యూ 9.8 తీసుకుంటే ఎగ్జాక్ట్ వాల్యూ కరెక్ట్ గా వస్తుంది. G వాల్యూ 9.8 తీసుకోవాలి. G వాల్యూ 9.8. G వాల్యూ 9.8. 9.8. సో ఇప్పుడు ఇది క్యాన్సిల్ కాదు. అప్రాక్సిమేట్ ఆన్సర్ చేయొచ్చు లేకపోతే 10 power of minus 1. 10 power of minus 1. So 9.8 into 10 power of minus 1. This one is 1 minus 1/2. 1 minus 1/2. That is equal to 9.8 into 10 power of minus 1. This is 1 minus 1/2 అంటే 1/2. So these two get cancelled. W is equal to 2 anja. This cancel 4.9. So 4.9 into 10 to the power of minus 1. So W is equal to 4.9 into 10 power of minus 1 అంటే divided by 10 అని. So 0.49. 0.49. This is joules. So this work is work capacity to do work is called energy. That is kinetic energy. Kinetic energy is equal to 0.49 joules. Yes. Option number 1. First option. Okay. Next. Next. Next, 12th one. Problem number 12. Problem number 12. A liquid of specific gravity is 0.8. Liquid of specific gravity is 0.8. Flows in a pipe line with speed of 2 meter per second. 2 meter per second. The kinetic energy per enable matter of it is. What is find? Kinetic energy. So what is given? Speed is given. Speed. Okay. Specific gravity is 0.8. 0.8. This is mass. Okay. Now find out kinetic energy. Kinetic energy. Kinetic energy. Yes. M is given. M is equal to 0.8 gram. M is equal to 0.8 kilogram, converted to kilogram, 0.8 into 10 power of grams, kilogram like marking out 10 cubed. So M is equal to 800 kg. M is equal to 800 kg. Speed is given. Speed is equal to 2 meter per second. What is find? Kinetic energy. So what is formula? Kinetic energy Ke is equal to half mv square. We know that Ke is equal to, substitute the values of into mass 800 into V 2 square. 2 square. So in this 1 2 cancel. So kinetic energy Ke is equal to, kinetic energy Ke is equal to 800 into 6 1600. What is units? Joules. Yes. Option is there. Second option. Second option. Second option. Okay. Second option. Next. 14th one. Problem number 14. Problem number 14. Two stones of mass M and 2M. Two stones of mass M and 2M are projected vertically upward so as to reach the same height. The ratio of kinetic energy of their projection is. So first option 2:1, second option 1:2, third option 4:1, fourth option 1:4. So what is given? Masses is given. Two masses. First mass M1 is equal to M, second mass M2 is equal to 2M. M1 is equal to M, second mass M2 is equal to 2M. Projected vertically upward, reaches the same height. Height is the same, but ratio of kinetic energy. Ratio of kinetic energy. Now find out K1 is to K2. K1 is to K2. Yes. K1 is to K2. Problem number 14. Problem number 14. Problem number 14. M1 and M2, two masses is given. M1 is equal to M. First, second mass, M2 is equal to 2M. Height is the same. Reaches kinetic energy. So, ratio of kinetic energy. What is formula kinetic energy? K is equal to half mv square. K is equal to half mv square. Kinetic energy is directly proportional to mass. Kinetic energy is directly proportional to mass. Ke1 by Ke2 is equal to M1 by M2. KE1 by KE2 is equal to M1 by M2. Substitute the values. Now find out the ratio of kinetic energy. KE1 by KE2 is equal to M1 value M by 2M. That is equal to these two get cancelled. So KE1 by KE2 ratio 1:2. KE1 by KE2 is equal to 1 by 2. 1:2. Yes, option is there. Second option 1:2. The option 14th one. Second option 1:2. Correct. Yes, remaining concept to tomorrow discuss about tomorrow conservative energy and collisions, conservative forces and collisions. Remaining bits, some bits tomorrow explain. Yes. Okay. So time up. Thank you everyone. Bye. ఎవరైనా స్లో రాసుకునే వాళ్ళు ఉంటే స్క్రీన్ షాట్ తీసుకోండి ఫాస్ట్ గా. క్లోజ్ చేస్తున్నా. Leave the meeting.